Good morning, everyone. My name is Ng Yen. I'm from course UHLB 2122, section 25, group 6, and I'm very honored to be here today. The title of our presentation is Bridging the Gap Between Engineering Student and Their Study. Before going to the presentation, let me introduce our team, which is me, Ng Yen, Muhammad Danish Kwakim bin Fazi, Muhammad Ammar bin Muhammad, Muhammad Akmal Daniel bin Ilash. Alright, the purpose of today's presentation is to discuss the challenges engineering students feel face in connecting their study with real-world application and explore how innovating teaching strategy can be bridge this gap. To begin with, let's explore why many engineering students feel disconnected from their study. As you can see from this mind map, there are several contributing factors. First, there is too much emphasis on theory, on textbook learning. Second, many students lack practice, expo, or hand-on project. Third, the teaching approach can often feel dry or disconnected from real world connection or needs. This issue makes it hard for students feel motivated and engagement. Now, let's move on to the breakdown on the problems. One of the main cause of the problem is lack of hand-on experience. As shown in tables, when there is little no opportunity to apply what's learned, students feel disconnected. If they spend monthly solving equations without knowing how they use in real project, it reduces their motivation. Eventually, this can lead to honors, lower academic performance, and even drop out. This flowchart clearly shows how traditional teaching methods lead to disengagement. It starts with lecturer-based learning. Then, there's heavy focus on theory with minimal real-world context. This causes students to struggle in applying knowledge. Finally, it results in things and disconnected from their field of study. Have you ever feel like what you learn in class does not connect with real world? This is exactly what many students going through. To quote a source from Erasmus, many students struggle to appreciate engineering when they can see how theory translates to real application. This reinforces the importance of connecting theory with practicals. Now that we understood the problem, let's take a look of the solution. In the next part of my presentation, I will explain how innovating teaching methods such as problem-based learning, design-based learning, and communicate engineering project are helping students engage with their education.
Okay, so in this part, we'll be talking about the effects of the problems about student disengagement in their studies. So we will be especially focused on their performance and motivation. So the first point is when students start to feel disconnected from their studies, what we can see is that there will be a decline in their academic performance. There will also be students that struggle with their coursework or fall behind on their assignment. So all of these negative things will lead to them on being underperform on their tests. So talking about this, the effects of drop in academic performance and motivation is very big on student disengagement. But also we will talk about motivation because it's not just about grade. When you have a drop in your motivation, you will lose your confidence to continue your studies or to keep up with the challenging field like engineering. There's when we talk about this, there's a research by Gizi Gunes, Chekaya and Sungur in 2009 that support this. They found a strong connection between motivation and learning outcomes. In other words, when students feel motivated, they tend to perform better. But motivation fades. The academic success suffer too. Moreover, the problem doesn't stop there. This engagement often affect class attendance and participation. Students may begin skipping lectures, avoiding group work, or staying silent during discussion. The more, the less they participate, the less they learn. And this cycle keep continuing over and over. So from time to time, this kind of pattern will create a feeling of inferiority and alienation in the students. So they will start to believe that they feel that they are not good enough. They don't have good confidence, or they don't have their own self confidence of their own identity as an engineering students. But this kind of pattern or cycle often keep repeating itself. So this kind of thing will result in much more poor performance of student academic and motivation. So that's why this cycle is called something like vicious cycle. Another kind of serious effect of this problem is that students will start to see that engineering courses as meaningless or irrelevant. So rather than viewing the curriculum as something that will shape their future, they see it as a series of hoops to jump through. Like they don't see that this kind of studies in engineering is an opportunity for them to learn or to take anything that they can so that it will be useful for them in the future. So this will lead to the mindset which is ineffective studies habits, which often happen in nowadays student, where they will keep copying other people work, they will just they don't have any kind of hard work to complete their own assignments or work. So as a result, this will make most of engineering students have a weak understanding of core engineering concept. So all in all, we can say that the effects of this engagement are quite wide. It all starts with poor performance and poor motivation, so and then it extends to ineffective study habits or feeling of inferiority or poor class attendance. So these kind of issues are really big when it comes about problem in student feeling disconnected with their studies. And this is all for me.
I will now explain some practical ways to help reduce the gap between engineering students and how they learn. Many students understand their theory in class but struggle to apply it in real life situations. This disconnect affects not just their academic performance but also their motivation and confidence. To address the issue, we will be explaining four practical solutions that can make engineering education more effective and meaningful. The first one is problem-based learning. Second one is hands-on learning. Third one, real-world project, and the last one is institutional institutional program. I will begin with the first two. The first one is problem-based learning (PBL). Problem-based learning is a method where the learning process begins not with theory but with a challenge. Students are placed in realistic scenarios where they need to identify the problem and figure out what knowledge they are missing. After that, they work together to come up with a unique and creative solution. Instead of receiving information passively, they are actively seek it out because they need it to move forward. Teachers don't give them direct answers but instead guide their progress. This makes students more engaged as they are solving something that fits relevant not just preparing for an exam. Next, I will talk about pros and cons. One of the biggest strengths of this method is how well it develops independent thinking. Students become more confident in asking questions, researching, and solving problems. It also sharpens their ability to work with others, which is critical in the engineering field. However, there are challenges too. Group work can be uneven because some students may contribute more than others, and since the learning is not always such a structure, some students can feel lost without clear direction. From a teaching uh, from a teaching perspective, it is also harder to assess who have learned what the task is shared across the team. Next, we look at the hands-on learning, which is the second solution. This approach allows students to learn by doing and not just by listening to the lectures. Whether they are simulating a circuit, running software, or designing something in AutoCAD, students get to apply what they have learned in a real and practical way. What's powerful about this method is that students often understand concepts better when they see them in action. They are more likely to remember something words after building it than after reading about it. It also encourages experimentation. When something doesn't work, they will adjust and try again throughout the learning process. Now, let's talk about hands-on learning pros and cons. Hands-on learning brings many benefits. It helps reinforce classroom theory, builds technical skill, and often increases student motivation. When students see that their work function in a real-life system, it gives them a sense of accomplishment and boosts their confidence. However, it does have its limitation. It requires equipment, time, and infrastructure who are well prepared to manage a practical environment. Without the right guidance, students might rush through activity without fully understand the theory behind them. And like with the group project, there is always the risk that some students do more while others stay in the background.
Now, let's move to the third solution, which is real world project. One impactful way to bridge the gap in engineering education is through real world project. In this project, students are given the opportunity to work in team to solve practical, real-life engineering challenge. This is far more than just an assignment, but it simulates that's what students will actually face in industry. For example, they might design a basic circuit using Proteus or simulate a mechanical structure in AutoCAD. By doing this, they're not just memorizing formulas, but they're applying them in ways that mirror real job expectation. This helps students not only understand theoretical concepts more deeply, but also improve motivation and engagement. When students see what they learn can be used to build something meaningful, they feel a stronger connection to their course. Additionally, real-world projects develop essential soft skills like teamwork, communication, and leadership. These skills are often just as important as technical knowledge when entering the engineering workforce. Students will work together as a team to solve real engineering cases as to improve their engagement and so many skills. Now, let's talk about how institution program can support this kind of learning. It is not enough to rely on one or two classes. We need system level support. That's where institutional program comes in. A well-designed program might integrate simulation tools like MATLAB and Proteus into multiple courses across the different semesters. This ensures students repeatedly apply their knowledge rather than just memorizing and forgetting it. This program can also include structured mentoring program where senior or alumni guide juniors and emotional support system to help manage their stress. All of this creates a more connected academic community. Students in this environment often report stronger academic performance, more motivation, and higher confidence. They feel they are part of something bigger than just passing a class, but they're also being prepared for being a professional career in their future job. That's the kind of transformation an institutional program can offer. For the conclusion, in the end, solving this problem is not just about improving test scores. It's about changing the way students can experience learning. This approach of real-world project, institutional support, and interactive learning can transform passive education into active growth. While it's true there are obstacles like cost and resource limit, this can be addressed with good planning, shared equipment, or hybrid model, combining virtual and physical learning. Ultimately, students become more than just exam ready, but they become career ready. And equally important, they become confident and supported, ready to take on the challenges of the engineering profession. That is how we encounter or solve the problem to achieve our topic, which is bridging gap between engineering student and their studies. I think that concludes our presentation. Thank you for your time and attention. We hope this has given you a clear understanding of how active learning can support not only the academic success of engineering students, but also their emotional and also bridging the gap between engineering students and their studies.